Look at a globe. What you're seeing is an illusion of stability. We call our home Earth, but that is a misnomer. We live on a planet of water. This water isn't just scenery. It is the blood, the thermostat, and the life support system of every living cell. What if we pulled the plug? Imagine a portal opening at the bottom of the Mariana Trench, the deepest point on the planet. If this drain were the size of a basketball court, it would take hundreds of thousands of years to empty the seas. But for the sake of our experiment, we are going to accelerate time. We're going to drain the oceans in a matter of hours.
As the water begins to recede, the first thing you would notice isn't the silence. It's the sound. A low-frequency hum, a planetary scale gurgle as the weight of the world's oceans shifts. Along the coastlines of New York, Tokyo, and London, the water doesn't just go up like a tide, it vanishes. Within minutes, the continental shelves, the shallow edges of our land masses are exposed. Thousands of shipwrecks, once hidden in the gloom, sit rusting in the sudden sun. The real horror is happening further out.
If you were on a cruise ship or a massive container vessel in the middle of the Atlantic, your world just ended. Deep sea water is roughly 4 to 6 kilometers deep. As the water vanishes beneath the hull, these billion-dollar steel giants become toys in the wind. It takes about 30 to 40 seconds for a ship to fall from the surface to the abyssal plain. They don't land gracefully. They hit the mud and silt at terminal velocity, shattering like glass. And then, there are the residents of the deep. For billions of fish, mammals, and invertebrates, this is a skyfall apocalypse. Whales, dolphins, and sharks are left flailing on a rapidly drying seabed. But even for the creatures already on the bottom, the crabs and the tube worms, survival is impossible. Why? Because of atmospheric pressure. Water is heavy. At the bottom of the ocean, the pressure is 1,000 times higher than at the surface. But what if the water disappeared? The air would rush down to fill the void. This would create a massive increase in atmospheric pressure at the new ground level. The air at the bottom of the Pacific would become so dense that it would behave almost like a fluid. If you were standing there, your lungs would collapse under the weight of the air itself. By the end of the first day, the Earth looks unrecognizable. The familiar continents are now massive, towering plateaus, rising 4,000 meters above a vast, brown, muddy wasteland. We have just revealed the abyssal plains, the largest and flattest habitat on Earth. But it doesn't stay mud for long. As the sun beats down, the moisture evaporates, leaving behind billions of tons of salt. The ocean floor becomes a white desert. This isn't just a visual change, it's a chemical one. Without the water to keep it stable, the salt begins to blow. These salt storms are toxic. They rise into the atmosphere and are carried by the wind onto the former landmasses, poisoning the soil of our farms and forests. But there's a deeper, more violent change happening under the crust. The Earth's tectonic plates are heavy, and the ocean water provided a massive amount of counter-pressure against the seafloor. Furthermore, water acts as a lubricant for subduction zones, where one plate slides under another. Without the weight of the ocean and the lubrication of the water, the Earth's crust begins to buckle. Volcanic activity spikes. Hydrothermal vents, no longer suppressed by miles of freezing water, blast superheated gas directly into the atmosphere. The ring of fire becomes a literal ring of erupting magma.
Now we encounter the most significant role of the ocean, thermal inertia. The oceans are the Earth's heat sink. They absorb over 90% of the excess heat from the sun and our greenhouse gas emissions. Water has a very high specific heat capacity, meaning it takes a lot of energy to heat it up and a long time for it to cool down. This is why coastal cities have mild weather. Without the oceans, the Earth's AC unit is gone.
The land heats up instantly. Within weeks, Daytime temperatures in former temperate zones like Europe or North America would soar to 60 degree or 70 degrees, 140 degree, 160 degree. Without water to evaporate and create clouds, there is no shade. The sun's radiation hits the ground with brutal intensity. Conversely, at night, there is no ocean to radiate stored heat back into the sky. Temperatures plummet. Planet swings from a furnace by day to an Arctic wasteland by night. Then, the water cycle stops. Every drop of rain that falls on your head originally evaporated from the sea. Without the oceans, there is no evaporation. Without evaporation, there are no clouds. Without clouds, there is no rain. The rivers, the Amazon, the Nile, the Mississippi, begin to shrink. They aren't being replenished. Within months, the great arteries of our civilization dry up into dusty canyons.
Many people believe that the world's oxygen comes from the Amazon rainforest. This is a common myth. While forests are important, about 50% to 80% of the oxygen you breathe is produced by phytoplankton, microscopic plants in the ocean. With the oceans gone, the phytoplankton are dead. The primary engine of our atmosphere has been cut in half.
At first, we wouldn't notice. The atmosphere is vast, and there's enough oxygen stored to last us for a while. But as the plants on land begin to die from the lack of rain, the CO2 levels begin to climb. And then comes the great desiccation. The world's forests are now standing tinderboxes. They haven't seen rain in months. The humidity is 0%. All it takes is a single lightning strike or a spark from volcanic eruption. Wildfires break out on a scale never before seen in human history. We aren't talking about a few thousand acres. We are talking about entire continents on fire. The Siberian taiga, the Amazon basin, and the Great Plains of America become a single, contiguous wall of flame. As the forests burn, they release billions of tons of stored carbon dioxide into the atmosphere. They also consume the remaining oxygen. The sky turns a permanent, sickly orange-gray, choked with ash and soot that blocks out the sun, but ironically traps the heat underneath, a phenomenon known as the enhanced greenhouse effect.
If the heat from the fires wasn't enough, a hidden time bomb under the seafloor finally detonates. With the water gone and temperatures soaring, these clathrates sublimate, turning from solid to gas instantly. Trillions of cubic meters of methane belch into the atmosphere. Methane is 25 to 30 times more potent as a greenhouse gas than CO2.
This is the tipping point. The runaway greenhouse effect turns Earth into a twin of Venus. The surface temperature climbs past the boiling point of water. Any remaining lakes or groundwater reservoirs boil away into the atmosphere, creating a thick, high-pressure shroud of water vapor, which only traps more heat. The Earth is now a pressure cooker. Life, as we know it, is over. Survivors, perhaps a few microbes living deep underground or near the remaining ice at the poles, are all that's left of the billions of species that once thrived on the blue marble.
As we zoom out from our brown, scorched and smoking planet, the lesson becomes clear. We often treat the ocean as a resource, a place to fish, a highway for trade, or a convenient dumping ground for our waste. We see it as something extra to the land we live on. But science tells a different story. The ocean is not just a feature of Earth. It is Earth. It is the lungs that breathe for us, a heart that pumps heat around the globe, the shield that protects us from the harshness of space. We don't need to drain the oceans to see them vanish. Acidification, warming, and pollution are already degrading this vital system. Our experiment today was a fantasy, but the fragility of our water world is a reality. Next time you stand on a beach and look out the horizon, don't just see a body of water, see a life support system. Because without that vast blue expanse, we aren't just a different planet. We are no longer a living one.